Hello friends, in this video we are going to discuss the first three intervals, equivalent circuit and voltage across each phase as well as line voltage, okay, for 180 degree conduction mode inverter, right? So as we already discussed about the circuit diagram and the operation table, okay, so now we are going to discuss the interval by interval, right? What is the output voltage, right? So if you check during the first interval, switch number 5, switch number 6 and switch number 1 will be in the on state, okay. So during the first interval, S5 will be in the on state, S6 will be in the on state, and S1 will be in the on state, okay. So S1, S5 and S6 will be in the on state, right? So if you check, this is like a phase A, this is the phase B and this is the phase C of the load, okay, and this is the neutral point, right? Here we have considered the load is star connected, right? So phase A is connected through S1 to the positive plate of the EDC. Phase B through the S6 it is connected to the negative plate of the EDC, and phase C through S5 it is connected to the positive plate of the VDC. Okay, so if you check, phase A and phase C both are connected to the positive plate of the VDC and phase B to the negative plate of the VDC. Okay, so can we draw the equivalent circuit? Suppose the load is resistive, for example, suppose the load is resistive, right? So here phase A and phase C, these are connected to the positive plate of the VDC, right? So we'll be having the VDC plus minus, this is the VDC, phase A and phase C, right? Phase A and phase C, these will be connected to the positive plate of the VDC, whereas phase B will be connected to the negative plate. So this is a phase B, this is a neutral point. Suppose the load is balanced, so in all the three phases the same resistor we will be having, right? Phase A and phase C, right? Phase A and phase C, A and C, these will be connected to the positive plate of the VDC, right? So A and C are connected to the plus VDC, B is connected to the minus VDC, right? And in between we are having the resistance, in between we are having the three phase load. Okay, so now if you check voltage between VAN, right, is equal to voltage between VCN, because these two phases are connected in parallel. Okay, so again R in parallel with R, can we replace it with R by 2? Yes. So further we can reduce this circuit as, yes, this is a VDC, we will be having VDC, next R in parallel with R, so it is a R by 2, next neutral point, and here it is a phase C we will be having, right? So this is the neutral point, this is a R, here it is a phase B, phase A and C are connected together, this is R by 2, right? Why it is R by 2? Because R in parallel with R. Okay, now so for this circuit, if we check, yes, we can write it as, by using the voltage division rule, right? We can write VAN is equal to VCN, right? Because the current will flow like this. Okay, so definitely VA is greater than VN, right? VC is greater than VN. Okay, so here VAN is equal to VCN, we can write it as, by using the voltage division rule, like R by 2 into VDC divided by R plus R by 2. R plus R by 2 is 3R by 2. Okay, so from this we can write it as is equal to, yes, so we can write it as VAN is equal to VCN is equal to, yes, VAN is equal to VCN is equal to, this 2 will get cancelled, RR will get cancelled. Okay, so it is a 1 by 3 VDC, right? So it is a VDC by 3. This is a VAN, which is equal to VCN. Okay, what about the VNB? Right, let us write it as a capital, because phases were considered as a capital. Okay, so what is the VNB? If you check, current direction is like this, so N should be higher potential than that of the B. Okay, so VNB we can write it as, with the help of voltage division rule, R into VDC upon R plus R by 2, that is a 3R by 2. Okay, So is equal to RR will get cancelled. So it is a 2 by 3 VDC, right? This is a VNB. Okay. So if we draw the plot, right, for VAN, VCN and VBN, VAN, VCN, VDC by 3, and it is a 2 EDC by 3, right? VNB is 2 EDC by 3. So what about the VBN? If you check VBN, VBN will be minus VNB. Okay. So therefore VBN is equal to minus of VNB is equal to minus 2 by 3 VDC. Okay, so here middle phase VBN is minus 2 by 3 and remaining 2 are VDC by 3. Okay, so it is like VDC by 3. Okay, so suppose, okay, so here suppose this is a VDC by 3, right? This step is VDC by 3, VDC by 3. Okay, similarly VCN is also VDC by 3. So this is also VDC by 3 we are having, for example. So we can write it as this is also VDC by 3. Okay. And what about the VBN? VBN is minus 2 by 3 VDC. Okay. So it is a minus 2 by 3 VDC. So I am taking from this pulse. Okay. Be careful. This is for VBN actually. Okay. VCN will be here. Okay. So this step is of minus 2 by 3 VDC. I am writing here minus 2 by 3 VDC, this step. Okay. Next, so this is for the first interval. Okay. Similarly, we can write for the second interval, right? During the second interval, if you check during the second interval, yes, during second interval, switch number 612 will be in the on state. Okay. Switch number 612. So let us discuss what will happen. Yes, switch number 612 will be in the on state. Yes, so it is switch number 6, 1 and 2. Yes, switch number 6 is in the on state. 1 is in the on state, right? 6 number switch 6, 1. 5 will be in the off state now, right? And switch number 2 will be in the on state. Okay. So it is a 612. 612 will be in the on state. So it is like phase A to the positive plate of the VDC, phase B and phase C to the negative plate of the VDC. Okay. So it is like phase A and B to the positive plate of the VDC, phase C to the negative plate of the VDC, right? So we will be having the equivalent circuit. It is like this. Phase A is to the positive plate of the VDC, right? This is the phase A. This is the phase A, right? R. And phase B and C to the negative plate of the VDC. Okay. B and C. Okay. So balanced load. This is the neutral point. Okay. Next phase B here, for example, phase C here. Okay. Next, now from this, can we say that these R and R connected in parallel? Yes. So it is like a R by 2. So we can, yes, redraw the network as this is VDC. Okay. Next, here it is a R ohm and this is a R by 2 ohm. Okay. So we can write it as a R by 2 here. This is a neutral. B and C points are connected together. This is a and this is a R. Okay. So further we can write it as, yes, this is a R, this is R by 2. Okay. So we can write VAN. With the help of voltage division rule, we can write VAN. Okay, VAN is equal to what? R upon 3R by 2 into VDC, right? So this can be written as RR will get cancelled, so it is a 2 by 3 VDC. This is the VAN. Okay, VAN. Similarly, we can write for VBN and VCN. VBN is equal to VCN. It should be negative, right? Because VNB and VNC are positive. Okay, so it is a minus VDC by 3. Okay, so from this we can write VAN is 2 by 3 VDC. VAN is 2 by 3 VDC. 2 by 3 VDC, right? So this step is of 2 by 3. Okay, this full step. Next, remaining 2 are VBN, VCN are minus VDC by 3. Okay, so minus VDC by 3. VCN is minus VDC by 3. So minus VDC by 3 means it will be like, okay, so minus VDC by 3. VCN means it will be here. It will be minus VDC by 3 means at this point it will be, yes, here it will be, okay, minus VDC by 3, right? You're getting the point? And this is the minus VDC by 3, so it will be at this location, at this position it will be, right? Okay. This is for the second interval. Okay, similarly, can we check for the third interval? Yes, we can. S1, S2, S3 will be the on state. Okay, S1, S2, S3 in the on state. So we can write S1 is on state, S6 off state now. Okay, S2 is in the on state. Okay, so if you check, S1, S2, S3 are in the on state. So further we can draw the equivalent circuit as, yes, so from this we can write S1, S2, S3 are in the on state. Okay, so therefore we can say that phase A is connected to the positive plate of the VDC through S1, phase B to the positive plate of the VDC through S3, phase C to the negative plate of the VDC. Okay, so here it is like, yes, we are having VDC, phase A and phase B will be connected together, right? And phase C here, this is R, neutral point R and R. Okay, phase A and phase B here, and here it is a phase C. This voltage is VDC. Okay, further R and R connected in parallel, right? So we can write it as R by 2. Okay, we can draw the circuit like this. Okay, this is a neutral point, this is a phase C, this is a R here it is a R by 2, here it is A and B, this is VDC we are having. Okay, so now from this we can write VAN is equal to VBN is equal to, yes, we can write it as a R by 2 upon 3R by 2. Okay, so it is a like EDC by 3 will be getting. Okay, what about the VBN, sorry, VCN? It is a negative, right? VCN it should be negative because current is flowing from N to C. Okay, so VCN will be negative. It is equal to minus 2 by 3 EDC, minus 2 by 3 EDC. Is this clear? Okay, so VAN, VBN, EDC by 3. VAN is EDC by 3. VBN is also EDC by 3. So it is a EDC by 3. EDC by 3, right? Next, VCN, sorry, VBN is also EDC by 3. So here it is a EDC by 3 will be having this step. Okay, and next VCN is a minus 2 EDC by 3. So it will be minus 2 EDC by 3. Is this clear? Okay, so if you check here, we will be having values like this is a 2 EDC by 3. Okay, 2 EDC by 3, right? This is a EDC by 3 we are having. EDC by 3. Okay, This is a minus 2 EDC by 3, minus 2 EDC by 3. Okay, here it is minus EDC by 3, minus EDC by 3. Okay, so in this way, this is for the first three intervals, right? So again, during the first three intervals, can we draw the plot for line voltages, right? I have shown here only two line voltages, but we can draw for the three also. Okay, no problem. So if we draw the plot for line voltages, yes, it will be like VAB is nothing but VAN minus VBN, right? So what is the VAB? I'm writing here VAB is equal to VAB is equal to VAN minus VBN, right? And VBC is VBN minus VCN. Okay, so we can write it as, yes, during the first interval VAN minus VBN, it is a VDC by 3 minus of minus VDC by 3, so it is like a VDC, right? It is like a VDC. Are you getting the point, right? So suppose this pulse is of VDC, this pulse is of VDC, right? Next, during the second interval, it is a 2 EDC by 3 minus of minus VDC by 3, right? This pulse will be of minus VDC by 3. Okay, so it is not EDC, actually it is a VDC, it should be VDC, I'm sorry, this should be VDC, right? So this should be VDC, okay, because now we consider it as a VDC. Okay, so now next, 2 VDC by 3 minus of minus VDC by 3, so again it is a constant, that is a VDC pulse. Okay, so this pulse will be having, it is equal to VDC. During the third interval, it is VDC by 3 minus VDC by 3, so it should be 0, right? During the third interval, it will be 0. Are you getting the point? Okay, next, what about the VBC? If you check VBC waveform, right, VBN minus VCN, it is a minus 2 EDC by 3 minus EDC by 3, so it is a minus VDC. Okay, minus VDC, it should be minus VDC, right? So I am representing here. Next, during the second interval, if you check, it is a minus VDC by 3 of minus of minus, right? So it is a plus, so it will be 0. So it will be 0. This will be 0. Okay, this is for the second interval. Is this clear? Okay, and what about the third interval? It is a VDC by 3 minus of minus VDC by 3, so it is a plus. It will be like this. This pulse is of VDC. Here also it is VDC. Is this clear? Okay, so this is about the waveforms and the circuit operation for first three intervals, right? In the next video, we are going to discuss the remaining three intervals, that is interval number 4, 5 and 6. Okay, thank you.